Welcome, Tyler. Let me first introduce, what this webinar is about. Today, we are going to talk about how to make video AI agile, without sacrificing agility. How do we deploy video AI? And with us today is Tyler Compton, who is a product manager at Aotu. And I'll let him introduce himself in just a little bit. Also with us is Phil Nelson, who you must have seen many times on this.
Hey, everybody. I'm still here somehow.
He's the content manager at opencv.org, and he puts together all the content for the webinar, video, etc. So Tyler, go ahead, introduce yourself.
Sure. Thanks, Satya. My name's Tyler Compton. Like you said, I am the product manager at Aotu AI for our flagship product called Brainframe. At Aotu AI, we've been using OpenCV since I think day one. It was like one of our first dependencies that we pulled in, and it helped us when we were just trying to get a product out the door. And it's carried us all the way till now, where it feels like we're optimizing every line of code. So super excited to be here and talk to you guys about this topic. About staying agile while doing video analytics.
That's great. And so, we can get just started with, what Aotu is, just a tiny bit of introduction about the company, and then we'll dive into the actual presentation. I have enabled screen share, so you can
maybe
go ahead and...
before we do that right quick, don't forget, folks, we do a live Q&A at the last 10 minutes of the show, last 10, 20 minutes of the show. Please use the Zoom Q&A function, that little button, and send those, and we'll try to answer them as best we can. Also, stick around to the end because there will be some sort of goodie. I'm not going to put it over too much, but just stick around. You'll be glad you did.
Yeah, thanks, Phil. We have been giving away, on every episode, we have been giving away something or the other. The very first episode, we gave away one Oak One. We have given away free courses. We have given away other subscriptions to paid, content. So we have some gift from Aotu in the end. Stick around till the end. And it is usually based on a question. We ask a question and ask the audience to respond. So the first one gets something, and the rest of the audience will also receive some discount. So let's get started.
All right. I'll go ahead and share my screen here. Okay, so we already touched a little bit on my background here, but I just want to talk a little bit more about our flagship product so you understand the angle that I'm coming from here. So at Aotu AI, we work on Brainframe. It is a generic solution to the problem of video analytics. We believe we've identified a set of key components that are required in all video analytics solutions, but are very difficult to get right. And Brainframe is made to solve those problems for you and make adding video analytics to an existing product a lot easier. So even though Brainframe is supposed to be a solution for a wide variety of problems, we've had the opportunity to work directly with a lot of developers on tailoring Brainframe to their needs. And like many companies that work directly with customers, we've made use of the Agile methodology to ensure that customers are tied into every aspect of the design process, and to make sure that we come up with a product that actually meets the needs that they have. Now, I'm not going to, in this presentation, attempt to completely define Agile. I think Phil said that Agile means a lot of things to a lot of people, and I think that's right. But I want to focus on three key components that I believe are both critical to Agile, no matter who you ask, and also that I think machine learning makes a lot harder. Because as much as machine learning has allowed us to tackle a wide variety of problems that 10 or 20 years ago we could have only dreamed computers would solve, it's also introduced a couple problems during development. But we think that we found some solutions to them, and I'd like to share those with you. But before we do, I would like to drill down a little bit on exactly what the problems are that we've identified working in this field. And the first one is on early delivery. So early delivery is the idea that you want to get a first release of your product to a customer as quick as you possibly can, right? And this ensures that the customer is involved in the process from the very beginning, and that the development team doesn't go too far in the wrong direction early on during development. The problem here is that if you've worked with machine learning models before, you know that making a good one is very time consuming, and it's also very tricky. And if you wait on your first...
It's also iterative in some sense, right? that
I'm sorry, what was that?
it's also iterative. You don't get the model right on the very first trial. You have to iterate over it to get it right.
Absolutely. Yeah. And chances are you don't have the data that you'll need to make that perfect model early on in development. And, we found that we get data entirely throughout the development process. We might be working on the model from the very beginning to the very end. Yeah, and this diagram here kind of shows that iterative process, right? And this idea that at any point in time, you might find that your labels aren't good, or the data isn't varied enough, or the model just wasn't trained properly. And this process is very tricky, and there are a lot of smart people trying to help make this process less painful. But the result is that you just can't wait.
Tyler, we lost you.
To release.
Okay.
So I also want to talk a little bit about continual improvement, this idea that you want to iterate on your release often and provide improvements to your customer early and often. The problem here is that you'll find that your model developers want to be free with their ability to change frameworks, model frameworks. You want them to be able to change model architectures to best solve your customer's problem. But the problem here is that it's very easy to write code that integrates tightly with the model technology that you've chosen. Which ostensibly solve the same problem, but are defined by two separate model architectures. And that has ramifications on the format of input that it gets and the output that it provides. And this, unless you're very careful, can have this fractaling effect on your code. And you can end up in a situation where you have to change a ton of code for what seemingly should be a pretty trivial change.
So I have this one anecdote that I might have shared before in a previous episode also about the need for this continuous improvement in AI models, because unless you are working in a factory setting, if your environment is not completely completely controlled, you will find these models will get outdated. And one example I have is, we had trained a person detector and it had a human in the loop system. So we would detect people, but small part of that set would also be sent to humans for review. And, this thing was deployed sometime in, spring or something. I can't remember exactly. But as we passed through the months, by winter, people started wearing these heavy coats, right? And you started seeing failures. And because we had this system which was continuously deploying, you could actually get, the model was updated. Otherwise, the person detector model would have failed because it did not have enough examples of people wearing these heavy coats. So that's something we got to be very careful about. It's very important that AI models should run on this continuous improvement phase, because the data could be gradually changing. It could be seasonal, it could be annual, but in general also, the data could be changing gradually. Like during the pandemic, suddenly the movement of the cars, right, the traffic on the highways, they decreased. So that could have led to some kind of AI model failure. So yeah, there is a need for this very important need for continual improvement in the models.
Yeah, with such a visual thing, you need to be able to actually inspect it with your human eyes to know if it actually works, unlike a lot of software.
Yep.
Absolutely. And we just to add another anecdote, we were working with a factory not too long ago, and we found that when early on in the product development process, they would have this beautiful factory, laid out by the engineers that was super clean, super well lit. And we were looking at this data being like, oh, this is going to be easy. This isn't going to be a problem at all. So we chose, small models that were very fast. And lo and behold, when they said, oh, well, we're going to start sending you some production data now, the factories are super dimly lit, right? The cameras are in weird places. You just never know when these changes are going to happen, right? And so being able to adapt to them is super important. In that case, we had to switch to a more powerful model and do a lot more training. And we were glad that our code was structured such that it didn't totally take down our pipeline. And that's a mistake that we've made in the past. So yeah, you just never know. No matter how hard you try to understand the scope of your problem, you're always going to be a little bit surprised. That's kind of part of the fun of software engineering, I guess.
Right.
So the last Agile topic I want to touch on here in regards to how machine learning affects it is a flexible response to change. So we already talked a bit about the idea of wanting to be able to switch out model architectures or model frameworks quickly, but even at a more macro scale, you may just end up in a situation where your customer just needs something different from what you expected. So in this example, we've got a situation where we've got a vehicle detector and tracker, but also a make and model recognizer. So, it might see a Honda Civic in the image and see it as a Honda Civic. But then we find out, oh, no, actually, all that the customer cares about is whether it's a sedan or a coupe. And that's a great opportunity to optimize your model. You probably need a smaller model for that. And it's probably easier to train too. But you want to be able to just completely take that model out and put it back in, and put a sedan coupe classifier in this example back in, without having cascading effects on the application. Because the application has to understand what you're providing to it. And if there's no pre-existing format where application developers can consume your data perhaps before the model is ready, you're going to end up in this chicken and egg situation where either the model needs to be designed first, or the application needs to somehow guess what the model will provide before the algorithm developers really know exactly what they're going to be giving you.
Right.
So I provided all these kind of clean diagrams of model architectures, but in my experience, if you're writing a bespoke video analytics solution to a problem, the code is going to look a little bit more like this. Lots of models spread around your code, lots of code required to attach them to each other, to attach them to the camera, do any format conversions, do any fusion of results, and finally get to your application. And kind of the problem here is that algorithm developers want to focus on the algorithms, right? They don't want to have to think too much about how you're going to use them, and beyond just the data that you're going to provide them. And application developers want to focus on what makes your application unique, right? The domain-specific requirements of the customer and how data needs to be formatted and all that. They don't really want to focus on this. Nobody wants to focus on this or write this code in the first place, because even though in a traditional video analytics application, this code is strictly necessary, it's just coupling, right? It's just stuff that keeps your code from being flexible. It keeps you from being able to iterate quickly or change to changing requirements. You just don't want this stuff, but how do you avoid it? And how do you end up in a situation where you can swap stuff out easily? So you might be tempted to think, this is just an Aotu AI problem. These guys don't know what they're doing, but and that may be true, but we're in good company. So this is from a white paper from Google, I believe, or from some Google engineers. And this is like our favorite white paper. It's called Machine Learning, the High Interest Credit Card of Technical Debt. And it talks about this idea that the way that you handle data and results from algorithms results in these very strange pipeline jungles, they call them, which is a wonderful term that I love. And it's very difficult to maintain these pipeline jungles. And so in case you're thinking that, maybe just tasteful engineering can get you past these problems, I mean, they will, but it's very difficult to get there. And, large companies with really smart people are still struggling to get there today. So
with that,
just to...
with that previous slide, the one before that, if we, not this one, 2 slides before this one.
The beautiful piece
right
of
here?
Postmodern art is what he's talking about.
Well, I think if you were trying to show spaghetti code, I think you have succeeded. Succeeded.
Yeah.
That's what happens with this.
I think it belongs in the Louvre.
Yeah, I mean, we were talking earlier. I'm trying to sell an NFT for this, make some extra side cash. I'm still working on the specifics there, but
Boo.
Yeah, it can be tough to visually show just what a mess we found ourselves in the past. Just to share another quick anecdote, we very early on in Aotu AI's life, before we learned these lessons, we wrote a product that was specific for a specific application. We were working with a company that needed to detect people and have some kind of understanding of their behavior. And we had this, right? We had the spaghetti code, but we thought it was fine because we thought we had a full understanding of our customers' requirements. But the requirements changed. And unfortunately, me and a lot of the engineers just so happened to be on vacation at the time. So I don't like to admit this, but we kind of like looked at the docs a bit and we're like, oh, I'm sure it's fine. And then, man, when we got back, we had work to do. I'm not going to say we had to completely rewrite the application, but we kind of had to completely rewrite the application. It was a hard lesson to learn, but kind of hard lessons are part of engineering, I guess.
Yeah.
So we've identified the problem here, and it's a big one, right? It's you want to be able to develop in an agile way, but if your technology prevents you from doing that, that really restricts your ability to fit a customer's needs. So let's talk a little bit about the solutions we've identified. So regarding early delivery, I really encourage people when they're first starting on a new machine learning application, start with off-the-shelf models. Whenever you can, start with off-the-shelf models. They're not going to be good enough for production. They almost never are. You're going to have to be doing some training. But being able to get out there in front and engage with your customers early with models that already exist is huge. This isn't always going to be possible, but for stuff like person detection, vehicle detection, and a lot of other stuff that you might not expect people have already done for you, they have. And using these models give you a big early advantage, even if they're not going to be good enough in the end. Regarding that, it's super important to set expectations with your customer. Help them to understand that the model's not going to be perfect from the beginning. No development is perfect from the beginning, but they're going to be involved in improving the model by providing data to you, potentially being involved in the labeling, depending on what your loop closing workflow looks like. And as long as you set expectations with the customer, they can come to understand that you're here to get a solution to them early, but also improve it over time. And you're going to end up with a great model in the end. But to that end, you really have to be comfortable deploying models that aren't done yet. A model is never going to feel done. And the more that you can provide those incremental improvements to the customer, the more encouraged they'll be to participate with you in this loop closing activity of providing production data to you, allowing you to improve the model. So it's critical not only that you do that, but that you have the infrastructure in place to do that quickly. For continual improvement, we're going to drill down a little bit into how exactly we're going to solve these problems. A really key component, if there's anything I want you to take from this talk, it's that you really want to isolate your models as components. That's critical. You want to isolate them to the greatest degree that you can, up to the point where it makes sense. And you want to isolate it enough that you can actually deploy your components independently of the rest of your application. That's something that I don't think is very common in applications, but we believe that it's really important because no matter how good your CI is, deploying an entire application is almost always going to be slower than deploying just one model. And having those deployments be separated allows your algorithm team to move at a rate that's independent of the way that your application team is running. That kind of separation doesn't come for free. And I'm going to share with you exactly technically how we do that later, but I want you to keep that in mind.
Yeah, and a very simple example, I'm pretty certain most people won't be making this mistake, but still it's worth pointing out that if you are, for example, deploying a mobile application and your model is tied to the application, just imagine submitting this thing to Apple and waiting for 7-14 days, whatever it takes for your application to get verified, where you could have just architected from the beginning so that the model gets downloaded or updated on the fly as needed, right? But there is more to it. We are not just saying that, okay, you have to separate the model from the code. It's bigger than that, that you should be able to change the model with a different input output without actually changing the application. And there are some tools out there which Tyler will also talk about. So it's very important that you should not be tied. The model should not be tied to the application. When you want to update the application, update the application. When you want to update the model, update the model. And hopefully you're updating the model more frequently than the application.
Yes, absolutely. That example regarding getting your application certified is one that didn't even come to my mind. But I mean, that's where it's even more critical, maybe not optional, to be able to iterate on your model more quickly than your application. So drilling down on that just a little bit more regarding flexible response to change. We want to talk about exactly what we need to refactor of our model into components. And it's not just the model, it's the supporting code around that model. The code that converts the model's output to a standard format, the code that takes standard formats from other capsules or other models and uses them. You really want this stuff to be inside of your deployable component because it's tied inextricably to the framework of your model and the architecture of your model. Formats are never the same between model frameworks or model architectures, and you really want to keep all of that detail inside of your encapsulated component.
Yeah, another example, I gave an app example. There are also times where the customer cannot afford a downtime, right? So you swap out the model in production in real time. And there it is super important that you're not redeploying the application, because redeploying the application means that you're going through this huge testing cycle and you're wasting a lot of time, and there could be a downtime. But if that's not a possibility, we work with some of the clients where it's not simply possible. They are working on so critical things, which works 24/7, that we have to swap out the model in production. And those kinds of things you have to be very careful about, so that.
Yeah, absolutely. That's a problem that we have to deal with on a day-to-day basis that this solution helps us provide. Since Brainframe is kind of a service, and other services depend on it, having Brainframe down can cause cascading failures throughout a customer's entire solution, depending on how they write it. And so,
as Spider-Man's Uncle Ben once said, with great power comes great responsibility.
That's exactly right. Yeah, absolutely. And we hope that we take that responsibility seriously. So yes, being able to swap models is critical at runtime, not only at runtime, but also between runs. So when I'm talking about some of these problems, some existing solutions might come to mind. And I do want to highlight them because I think they're important parts of the industry, both now and going forward. The first one is the TensorFlow Object Detection API, which does attempt to solve the problem I was talking about regarding different models having different formats, even for the same solution to a problem. Its scope is naturally somewhat limited. It's limited to TensorFlow models and specifically TensorFlow object detection models. So it doesn't attempt to provide a broad standard for input and output of model formats. But I thought I'd highlight it. It's something that we use. I think it's an important part of the industry as it is today. It just doesn't completely solve the problem I was discussing. And also Onyx, which I'm really excited about, is a standard format for models that's supposed to be able to work across frameworks. It's supposed to work across, whether it's a detector or classifier, or maybe even something not related to video analytics at all. And that's really exciting. And I think it's like a critical part of the industry going forward. We need to get past all of these bespoke model formats for every framework. But it doesn't try to solve the problems that we've identified necessarily either. It doesn't talk about the input and output of the model. It doesn't do anything for you regarding in detail how the model is loaded. Really great technology. It's just not a complete solution to the machine learning agility problem.
Yeah, I see Onyx as a portable format, right? That's about it, right? But for the things that we discussed, you need the entire system, right? A portable format is great, but you need an entire system.
Exactly, right. It's a bit like comparing, something like a comma-separated values file that works across Excel and Google Sheets to Excel or Google Sheets, right? There's a difference between defining a format and a framework. And I think what we're discussing here is more solved by a framework rather than a format. So just to make sure we're on the same page here, here's the missing pieces, right? No way to abstract models, no story for deploying these models, no format for communicating between these models, and no clean way to define dependencies between models. So at Aotu, we saw that there didn't appear to be existing solutions that solve these problems, at least in a flexible enough way that we could integrate it into our application. So we decided to make one. So I'm really excited to introduce or reintroduce Open Vision capsules to the world. It's the name of the framework that we defined that we believe solves all of the machine learning agility problems that I identified. It's completely open source. We want everybody to be able to use it. It's BSD licensed, and it's designed to, although we made it for Brainframe, we designed it to work with a wide variety of video analytics applications. But let's talk a little bit about what exactly it does.
One other thing that I want to point out, that OpenVision capsule is part of the main OpenCV. It's not part of the OpenCV repository, but it is inside the OpenCV, list of repositories. So when you go to OpenCV on GitHub, you will see OpenVision capsule as well.
Yeah, I just posted
exactly
the link.
Right.
I just posted the link in the chat there, and we'll make sure to put it in the YouTube description as well.
Absolutely. Yeah, please do check that out. We're really excited to have worked with OpenCV on this. We believe we have kind of a shared desire to provide this tooling to the world that makes using machine learning applications easier. So it just seemed like a perfect fit for both of us. OpenVision capsules, first of all, defines the format for what we call encapsulating vision algorithms. It takes in the model and the supporting code and puts it into a single file that can be copied over SSH, uploaded to an FTP server, whatever. It's just a file. And then added dynamically to your application in a directory or maybe uploaded through an API. It defines a format for communicating inference results between capsules and to your resulting application that remains standard and the same across different model formats and architectures, and that application developers can depend on when they write their application, perhaps before the models are finished. And we also provide tools for encapsulating your algorithm. We want to make this easy both for us and for you to use capsules with the formats that you already know and love. So we have existing support for TensorFlow and OpenVINO and anything that supports OpenCV's DNN module. And we're looking to add to this list over time. And it's always possible to use a model format that we don't have utilities for, but these are supposed to be made extra easy for you. So a critical part of capsules is that they're self-describing. And by that, I mean, they have to define exactly what they expect to take as input and exactly what you can expect them to provide as output. And this allows for OpenVision capsules to do something really nice for you. And that's understand holistically the dependencies that every capsule has and wire them up for you. So that pipeline jungle that we're talking about earlier can be written for you by OpenVision capsules dynamically. And you just end up writing a lot less code with OpenVision capsules because you don't have to talk at all about explicit capsule dependencies, and you can switch them out so much more easily. So the result here is the dream that we were trying to achieve. Algorithm developers write the capsule code. They don't have to worry too much about how they're going to be used beyond just what kinds of data are going to be inputted into the capsule at a high level. Application developers need to focus just on taking video as input, putting it into the OpenVision capsule system, and taking standardized formatted output data to their application. And OpenVision capsules does all of the work of attaching these capsules together so that you never have to write code that couples capsules together or does the kinds of format conversions that you just don't want to have to deal with. And so algorithm developers are happy and application developers are happy. So just to make this a little bit more concrete, I wanted to show you a really quick, like 20-second demo showing Brainframe using this system. This is admittedly a bit of an older version of Brainframe, but if I full screen it here.
Tyler, before we do that, could you explain the relationship between Brainframe and OpenVision capsule so that the viewers can understand?
Yeah, absolutely. That's a good point. So we designed OpenVision capsules because of problems we identified developing Brainframe. And so OpenVision capsules is Brainframe's runtime for running machine learning models against video information. So while you don't necessarily need to use Brainframe to use OpenVision capsules, they're designed to be completely separate. This system, Brainframe is just our kind of UI-driven way of demonstrating what OpenVision capsules can do for you because it's our application that uses the library.
Got it. Thanks.
So on the left here, you can see the videos that we have connected to Brainframe. On the top right, you can see a bunch of capsules that we're able to drag in. And on the bottom right, we have the capsules directory, which is where Brainframe looks for capsules and loads them dynamically. So as you can see, we're dragging I believe that's a person detector in, and we're going to drag a person encoder in as well, and a tracker. And so after Brainframe sees that these files have been introduced, it will load them up, and you can see now that dynamically we've gone from having no analytics to person detection analytics. And I don't know if you can see it over Zoom, but there's also lines following the person showing that they're being tracked. And these capsules can be removed and introduced as necessary during runtime, and they'll be hooked up to each other automatically. Okay, let's see if I can get back to full screen here. So if any of this seems interesting to you, I highly encourage you to go check it out. Like Satya mentioned, Open Vision Capsules is released under the OpenCV GitHub group, and it's all open source, and you can see the whole thing there. We also have really expansive docs for you to help you get started on Read the Docs that you can find here. And because Open Vision Capsules is just a Python library, we also have it made available on pip, so it's super easy to install. And if that little taste of what Brainframe does seems interesting to you, I'm going to be doing a webinar with OpenCV again in the near future that digs in a little bit more into Brainframe and how we made it and what it can do for you. So please check that out if you're interested.
So I have a question. Now, suppose people install, pip install Vision Capsule. What do they exactly get, with that piece of code? What you showed us was Brainframe, right? But with Open Vision Capsule alone, without Brainframe, what can people do with the piece of code?
That's a great question. So first of all, Open Vision Capsules is split into two separate components, and you can see it in this pip install command. There's VCap, which is just short for Open Vision Capsules, and that includes the framework that doesn't have any specific ties to model frameworks like TensorFlow or OpenVINO, and VCap utils, which provides those module loading utilities that do have dependencies on model frameworks. So what you get from here is the code that we use in Brainframe to load models. You get the code that works on attaching all of the capsules together into a automatically generated pipeline jungle, and also code that makes it easy to load up capsules and free them dynamically. So there's actually very little that you're not getting through Open Vision Capsules. There isn't actually a lot of supporting code in Brainframe that we need in order to use this, but it should not be difficult, and we have examples in our docs to integrate this system with your application. There's really just a few functions you'd have to call to make that possible.
That's great.
So I don't know if that answers your question.
Yeah, that answers the question. I mean, I think people should just go and try it out and read the documentation. That would give a good idea on how to use it in their application, right? And this is completely open source, right? This particular Vision Capsule, as long as you're coding to the standards laid out, you can swap out different models in your application without having to worry. It doesn't communicate with any of the Aotu server or anything, right? It's standalone. Is that correct?
That's right. Yeah, we want this to be used by as many people as possible. So there's no Aotu specific stuff in there, no Brainframe specific stuff, no telemetry, just an open source library like you would expect.
Yeah.
I also should mention that we have made available a what we call a capsule zoo. It's kind of like a TensorFlow model zoo. And we've adapted many both open source and in-house developed models to the capsule format for you. And all of those are also very permissively licensed. I believe it's also under BSD. So please feel free to use those. Like I said, it could really help with that early development, or I should say early deployment problem, to be able to use those. And because of the way Open Vision Capsules works, you can just kind of drag them into your application. So yeah, right. Please do check those out. I'll work with you guys to get a link into the description for that too.
Great. So from what I understand is if people download this code, they will be able to, let's say, download some of the capsules. Let's say you download a person detector capsule, you download a person re-identification capsule, then you can have multiple streams coming in. It supports multiple streams of videos, right?
Mm-hmm. Okay. Yes, that's right. It does. That's a really important component here. This is supposed to be entirely production ready. So yeah, it's able to support multiple videos at a very high throughput, depending, of course, on the models that you use.
So on those video streams, suppose you have two webcams or something, you can easily apply these person detector, also person identifier on both of these streams, right? Is that correct? Okay.
That's exactly right. And I don't want to get too into the weeds, but Open Vision Capsules has a system we call stream state that allows capsules to attach information on each stream that they are connected to. And that this can be particularly useful for trackers and stuff like that do have state that that exists between frames for the same video. So yeah, multiple video input support is first class in Open Vision Capsules.
That's great. One final question is there, of course, all the models will run on all the frames. Does the re-identification work across frames, across video streams? Like you identify some person here, can it be re-identified in the other frame?
Yes, it definitely can be. So what Open Vision Capsules will give you, or what the encoders that we write will give you, is some kind of, it's supposed to be kind of like an opaque string that encodes, for example, the what a person's face looks like, or whatever the case may be. And you can use that. You can compare that against results in any string. We don't provide an Open Vision Capsule as a way to store that information, and that's just because every domain is a little bit different there.
Right.
You may want to store it in a database or in a file system or something, but there's no restriction that would keep you from being able to detect, for example, faces across any number of video streams, no matter where the video files or video frames are coming from.
Got it. So basically you could, as long as the cameras are reasonably similar, this handover could work. As a person is moving from one camera to the other, you can hand over the identity of the person, right?
Yes, that's exactly right. And how durable a given model will be to different lighting and camera circumstances is of course going to depend on the model, but generally speaking, the models that we've worked with have been trained in such a way that they're pretty durable to that kind of thing. So yes, you shouldn't necessarily even need to use the same camera model, although that would be ideal. Yeah. As long as they both have a good, solid camera angle to see whatever it is you're trying to recognize, you should have no problem recognizing them across different video streams.
That's great. We can take questions from the audience now.
All right. Yeah. Before we get to that, I want to quickly point out to folks, there was a huge blog post update on the OpenCV AI competition 2021. I'm posting a link in the chat here. Hope you all take a look at that. We featured profiles on 3 of the teams, the Cortic Tigers, Egypt Iris, and Team Coda, which is making a cool robot arm. We also did some little bit feature on Charlie, the super robot, one of my personal favorite projects. So please check that out. As for questions,
covered on Hacker News, so that's it was second on Hacker News recently, yesterday.
Yeah, it was nice to just kind of stealthily sneak up there. As for actual questions here, let me pull these up. So first off, I'd like to, Henry has the question, does Open Vision Capsules support mask segmentation contours that format the mask RCNN's output?
So Open Vision Capsules, the standard format for communicating between capsules, does not specifically support contours, but it does support defining whether it be a bounding box or a non-bounding region within a video frame with any number of points, which we found to be a bit more generic for a larger variety of models. So for our models that do segmentation, we use I believe it's a pretty simple algorithm to convert those contours to a set of points. So while directly, no, there's no support for contours specifically, there is a support for the broader problem of segmentation.
Tyler, if you don't mind, could you stop screen sharing so that people can see you replying? Okay,
oh, yeah,
great.
Good call.
Thanks. Cool. Thanks for that. Up next, we've got another one about from Henry. He'd like to know, do the capsules automatically detect or require GPU hardware, or will they fall back to CPU if no GPU is available?
So I guess yes to both. So it depends on the model framework that the model is using, which usually controls how it's loaded. But for example, with our TensorFlow support, yes, it will try to apply itself to either one or a bunch of GPUs, depending on what the capsule supports. And if no GPUs are available, it will just fall back to CPU support. For OpenVINO, it supports running on both CPU and what OpenVINO refers to as HDDL devices, I believe is the term. So we're talking about stuff like the Movidius X and things like that. It will try to find any of those that it can, and if it can't find any, it will just run on CPU. So we tried to design it such that a capsule will never fail to load. It will always find some compatible device to run on.
Speaking of the Myriad X, I'd like to encourage all of our viewers to shop and get themselves an OpenCV AI kit with depth. They're in short supply from what I understand. I just dropped the links in the chat. You can buy them from Mauser or the OpenCV store. Absolutely. Next question. Does the machine running VCAP need an internet connection to work, or is it totally functional on the edge?
This is completely functional offline. There is no internet connected component to this library. So use it however you like on any device that you need to use it on.
What about support for IP cameras?
So Open Vision Capsules is actually agnostic to video formats, and it does not take care of connecting to a video for you. But if I can make a little OpenCV plug here, the OpenCV video capture object can often do a surprising amount. It even has support for custom GStreamer pipelines and stuff. So you can come a long way just writing a few lines of OpenCV code, connecting to an IP camera or webcam or whatever the case is, and feed the frames into Open Vision Capsules that way.
That's great.
Cool. Oleg would like to know where they can find the capsule zoo.
Yeah, so that's a great question. It's on, I'll make sure that we put a link somewhere, but it's under github.com/Aotu AI/capsule_zoo. And we do manage that under Aotu AI because we iterate on it a lot more quickly, but it's still completely open source. It's just this is kind of like Aotu's open source capsules for the kind of broader OpenCV affiliated mission of Open Vision Capsules, I guess.
Awesome. Thanks. And thanks, Alex, for sticking the link in chat there if anybody wants to click over. Next, we have a couple of good questions here. I'm going to break in and ask one of my own, actually, which is, what is the funniest failure you have seen when trying to, build something with Open Vision Capsules?
Oh, that's a good question. So I think that So one thing that can always be tricky, depending on the model that you're using, is figuring out what it's supposed to have as input. So sometimes we'll accidentally put in an RGB model that's expecting a BGR, or I'm sorry, you can put an RGB frame to a BGR model and you'll get just crazy results. And you'll feel like an insane person looking at these terrible results and seeing people on YouTube demonstrating how amazing this model is, until you realize what you did wrong. That's happened to us more times than I care to admit. There was actually a bug in one of our really prime capsules that we had in deployment where we were providing just the wrong kind of frame format. And the model was so good that it actually worked. But we got like a 20% precision or accuracy boost just from fixing that bug. So we felt a little silly finding that out. But that's the kind of stuff that can happen, right?
It's not the number of lines of code, it's the value of those lines, right?
Absolutely, well said.
Here's another good question about deployment here. The Vision Capsule models performant on Raspberry Pi, could you deploy them on a standard like Pi 4 and have them run how you'd expect?
There's no technical reason at the Open Vision Capsules level why Capsule couldn't run great on a Raspberry Pi. The question is just, is the model that you're running realistic for the hardware? And do you have any like model accelerators, for example, like the Movidius attached to the Raspberry Pi? I think you'll find that depending on what you're working on, you're going to have a pretty small model to run it on a Raspberry Pi CPU. But once you have those accelerators, the possibilities become quite a bit more significant. So yeah, open vision capsules can absolutely be used for that. It's not something that we've personally used it for. We tend to deploy on platforms that do have accelerators, but yeah, there's no technical reason why it shouldn't run just fine.
Yeah, and because it's open source, people can make a, if they want to make a smooshed down Raspberry Pi compatible version of a model and release it, there's nothing stopping them from doing so.
Yeah, absolutely. And if you want to contribute any of that upstream, I promise you'll make a good few engineers at Aotu very happy. So, and we're friendly too. We don't bite. So highly encouraged.
Excellent. So how should our viewers follow and subscribe to you personally, Tyler?
Well, for me personally, I'm on YouTube and Twitter under Velovix. For news regarding the company and stuff like that, we're on Twitter and YouTube under Aotu AI. So I'm going to be, you'll find me on both platforms. Yeah, feel free to tweet me if you have any questions about this stuff. I'd be happy to talk to you.
If anybody wants to hit you up by email, how would they do that?
Right. So you can email me at tyler.compton@Aotu.ai or at Aotu.ai. That's probably the best way to reach me. Yeah, feel free to email me too. I really like talking to people about the video analytics problems that they find, and I'd love to help you out and see if open vision capsules or some other technology we're working on can help with what you're doing.
Great, thanks a lot. One more question from the audience here. Are you willing to share your slides from your presentation today?
Yeah, I'd be happy to. We can
put it under the YouTube video. We released this webinar. So if you share the slides with us, we will share it with the audience, right, with the YouTube video.
Okay, yeah, that sounds good. I'll, I guess, stay tuned for that.
Do you have a question for the audience for the giveaway? We can, if you have two questions, we can ask two questions, or if you have a single question, then we can, give it away to the first two people,
Okay, yeah. So let's see, a question from me. I guess I would be curious about what's the craziest, or let's see, are you looking for a more technical question or a fun question?
We're looking for more of a trivia question.
Whatever question that we can give, the person who answers that question first gets, the goodie that we have promised, right? And there are two that Phil is going to announce. So we have two. If you have two questions, we will give it to the winners of the two questions. Or if you have one question, then we can give it away to the first two who answered that question.
Okay, gotcha. Let's see here, a trivia question. Let's see, I wish I'd come prepared with one. I suppose I would be curious. Sorry, I'm kind of running a blank right now. Okay, well, I have fun questions. So I would be curious what people's craziest app idea somebody has come to them with. Bonus points if it's machine learning related. I know that for me, as soon as I tell somebody that I'm in the field of computer science, they want to tell me their new Tinder for people who work out idea or whatever. So I'd be curious what the craziest idea you've had to talk somebody down from is. And I guess as far as a more technical question is concerned, I'd like people to know, I'd like people to answer what would be the model framework that you would reach for if you are deploying on an edge Intel platform. So for example, something running in Atom or something like that. What would be the framework that you would reach for?
Word. So I have a better trivia question here.
Sure,
so
go ahead. Yeah, sorry.
Get ready, chat. Earlier in the presentation, there was a slide that encouraged you to use a specific command to install vcap utils. What did that use?
Okay, I like it. I like it.
All right, we already got it. All right, looks like looking at the list here, we got, wow, there were so many so fast. It's like Ann Kristen Meisner was number 1, followed by, sorry, Andy, you can't win 3 in a row, man. It's like Vinicus Granja was number 2. Thanks everybody. Wow, you're always all just so Johnny on the spot with the answers.
So what did they win?
Tell them what they've won. So what those 2 have won is Brainframe Developer Edition for 12 months for free. That is a value of over $1,400. And the second winner gets Brainframe Developer Edition for 12 months with slightly fewer streams, which is only $700 in value.
That's great. And what about the rest of the audience if they want to try something?
The rest of the audience will be getting a discount on Brainframe that we will send to you via email as a thank you for sticking around during the webinar.
All right. Yeah, so thank you so much. One other thing that I want to mention is that Tyler would be on the webinar again after, maybe a month or so, where we'll do another live demo kind of thing. It would be more hands-on experience with what Brainframe is able to do and how you can build applications around it. So right now we wanted to keep this thing high level and focus only on the Open Vision capsule, but the next one would focus a little bit on Brainframe and how you can build real world applications around it. So
yeah, that's right. I'm super excited to come back. Please stay tuned if that sounds interesting to you.
Yeah, thank you so much, Tyler. I think that brings us to the end of the episode. Phil, thank you for all the support, and that's it. We will post this video on YouTube afterwards.
Yep. Thanks for joining us, everybody. We'll see you next week, 9 a.m. sharp.
Bye.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter or follow us on LinkedIn. And thanks to this week's sponsor at OpenCV.ai, premier consulting services in vision and AI.